Good evening friends, this is Professor Vishal and I am going to teach you physics from 9th standard state Maharashtra State Board. Okay, and in today's session we are going to see the chapter, name of the chapter is friction. Okay, now when we discuss about the friction, or in this session we are going to see this is the content of my today's lecture. First we are going to see the concept of friction, then we will see the definition, then what are the various factors that affects the friction, then what are the various causes of friction, then how friction is classified, or we can say types of friction. Then we are going to see the effects of friction. As we already know, in some cases friction is desirable, and in most of the cases it is avoided. Okay, so we will see the effects in both sense. Then we will see the methods of reducing and increasing the friction. As we already discussed, the examples, or where are the applications where we need frictions, or where there are some applications where we need to reduce the friction. So we are going to see the various methods. Then we are going to see the advantages and disadvantages, and then the applications. Okay, and whatever the questions, if you have any doubts, you can ask me. Okay, now we will start. When we discuss about the friction, we will see this concept of friction with the help of an easy example. Okay, so when we throw a ball on the floor, let us say our cricket ball, what will happen? It starts moving with some velocity, isn't it? But once it is rolled, ideally, what means once it is rolled, actually there is no force acting in the direction of motion of that ball. So as we all know, the Newton's first law of motion, that says every body is in its state of rest or of motion unless and until some external force is acting on the body, isn't it? So that ball is moving continuously, and it will not stop unless and until some force is acting on that ball, isn't it? So the ball should keep on rolling. Actually, according to the Newton's law, the body in is state of rest or of uniform motion, isn't it? But this does not happen. Why? Because the external agency, according to the Newton's law, unless and until there is external agency acting on that ball, so that external agency is nothing but the frictional force. Okay, now the ball stops after moving certain distance because a force is acting on it, isn't it? So that force is nothing but the external agency, and this particular force is we commonly called as a friction. In short, what we can say, according to Newton's law, when I throw a ball, it is in continuously running motion, isn't it? Unless and until some external force is acting on it. But that external force acting on it, and it's slow down its speed, so that external force is, or that particular agency which is responsible to decrease the speed of the ball, so that particular agency is known as frictional force, isn't it? Or it is known as commonly friction. Okay, now basically how we can define the friction? See, the scientific definition for friction is like this. Friction is nothing but the resistance offered by the surface that are in contact with each other when they move over each other, or we can say one surface is moving over the other. So basically it is nothing but the resistive force, we can say, isn't it? So which is offered by the surfaces which are in contact which are in contact with both of us. Okay, or one surface in contact with another, we can say. Now the frictional force, or we can say the friction, is a particular type of force that opposes the relative motion between the two surfaces of object in contact. Okay, or we can say friction is nothing but a force that opposes the relative motion between the two surfaces which are in contact with each other. Okay, we will see one simple example. Sorry, I will give you one example. Let us say this is the surface. Okay, and ball is rolling on the surface. This is the ball. Okay, now what will happen if motion of the ball is in this direction, then friction is what? Friction will act in opposite direction to this. Means what? It is by nature it resisting the motion of this ball, or we can say it resists the motion, or it opposes the movement of this ball, isn't it? So this type of force is nothing but frictional force. So if this is the motion, we can say this is the frictional force. Okay, so in this way we can say that the friction is the force that opposes the relative motion. Okay, so in this case two surfaces are the surface of the ball and the ground surface, okay, on which it is rolling. Then friction works in the opposite direction in which the body is moving, as we already discussed. So in this example, see, the ball is moving in this direction, and friction will act in opposite direction to the motion of that ball, isn't it? So we can say that this friction works in the opposite direction in which the body is moving. So, and what will happen because of this force? It will reduce the speed of that particular body, or we can say in this it will decrease the motion, or it will create retardation in the motion. Okay, so in this case, the because of this frictional force, the speed of the ball is getting slow down, isn't it? So friction is when we discuss about friction, in there are two sides of friction. Most of the cases friction is desirable, and most of the cases the friction is non-desirable. Okay, we will see this concept in further part of this presentation or the lecture. Basically friction is useful in most of the cases, and we can say for example, if we see how friction is useful to us, basically when we see the example of let us say we are walking on the road. Okay, so what will happen if there is a no friction? It is not possible to walk me with ease. Okay, so it will get sliding down, and it is not possible to walk with me. Or let us say we are running our two-wheeler or four-wheeler. Okay, if there is a no friction, what will happen? The particular vehicle gets sliding down. Okay, and it may cause the accident. So there are various applications where we need the friction. And on the other hand, friction is also non-desirable in some of the cases. Okay, now we will see one by one. See, the friction is also dependent on the external factors. Now we will see these factors. What are the various factors? So we will see here factors affecting the friction. Okay, we can say that basically there are two factors. Firstly, we will see first factor. Firstly, we can say the friction is affecting, or we can say the factors affecting the friction. First important factor is the nature of the two surfaces that are in contact with each other. So this is the most important factor. Okay, now see, as we all know, friction is resisting force, isn't it? Now friction is dependent basically on the smoothness or roughness of the two surfaces that are in contact with each other. When the surface is smooth, the friction between the two surfaces reduces, because there is no much interlocking of there is no interlocking, we can say there is no interlocking of irregularities taking place. While the surface is rough, the friction increases. Why? Because more irregularities are there, and interlocking takes place, and we can say the friction is more. Okay, so I will give you the one example here. Okay, we will see the concept of interlocking here. So let us say this is the surface, we can say the road surface, which is somewhat like this, and our tire surface is like this. Okay, if there is an interlocking between two surfaces, we can say that there is a no major friction. And on the other hand, if we if you see, let us say the road is uneven morely. Okay, and your surface is like this. So if this interlocking does not happen, we can say the surface is rough, and we will have a more friction, we will have a more resistance, isn't it? So in that case, we might have face the problem of we have to reduce the speed of our particular vehicle, isn't it? So in this way, it is more about the irregularities. Okay, when the surface is smooth, the friction between the two surfaces gets reduces, because there is no much interlocking of irregularities. When the surface is rough, friction increases, we will generally see. Okay, Now, second important factor is on the force that is acting on the surface. Now, when we discuss, as we all know, the friction is one kind of force, isn't it? So when the force is applied along with irregularities, what will happen? The friction will increases. If the force is low, the friction will always low, isn't it? Now we will see next, what causes the friction. This is most important question. So what is the main cause of creating friction in the system? Okay, now we will see. So we are on this slide. Okay, so when we see any object, we can see the smooth surfaces, isn't it, by our naked eyes, but we cannot see the irregularities on that object by our naked eyes. Okay, when we see the same object under the microscope, what will happen? It is observed that even the smooth appearing subject by our naked eyes, actually it has a rough edges, or we can say irregularities on its surface, like tiny hills and grooves can be there. Okay, when we observe under the microscope. Okay, and they are basically known as irregularities, isn't it? Now then we can say, when one object is moved over the other, as we seen in the definition, one object is moving over the other, these irregularities on the surface get engaged with each other, isn't it? So both surfaces having irregularities, and both irregularities gets engaged, as we discussed. Okay, so what will happen when they will engaged? It will give rise to the friction, isn't it? If they are not properly interlocked, what will happen? There is a friction, there is a reduction in motion. So when we can say that more the roughness, more will be the irregularities, isn't it? If your surface is irregular, or what we can say with the help of general example, we might have crossed the roads in rural areas, isn't it? So these roads are very rough, or we can say irregularities are there. So on that road, it will take too much time to travel, isn't it? So compared to good road, what it means, the more the rough surface is there, more will be the irregularities, and greater is the value of friction, isn't it? So this is the most important concept. It is all about irregularities, we can say, isn't it? Then we will see classification of friction. So accordingly, there are various types of friction, but basically frictions are classified into 4 types. First one is a static friction, the next is a sliding friction, third one is rolling friction, and fourth one is fluid friction. So basically, when we discuss about these types of friction, they all are different from each other, isn't it? Okay, now we will see how they are different from each other. We will start first with the static friction. Okay, now when we discuss about the static friction, so in this type of friction, the frictional force that acts between the surfaces when they are at rest with respect to each other, basically this friction, as its name indicates, it is a static. When two surfaces are in static position or in resting condition, at that time the frictional force is acting between the two surfaces. That force is known as that particular friction is known as static friction. Okay, so we will see one simple example of static friction. So let us say I am discussing about let us say one surface is there. Okay, and I am going to put one box here. Okay, so let us say this surface is, whether it is fixed or free, it doesn't matter. I will redraw it. Okay, let us say this is the box. Okay, so what will happen if we see this common surface? Okay, so what will happen? Because of the irregularities on the surfaces, there is a friction, and this type of friction, it is most important that this block is also in resting condition, and this surface is in resting condition. There is no motion, though there is a friction. So this type of friction, or we can say the friction occur in that particular area, is known as static friction, isn't it? So this is most important. Now we will see the examples of this type of friction. Okay, so we have seen the skiing against the snow, generally in the during the snowfall. skiing against the snow is particular example of static friction. Then we have seen creating heat by rubbing both hands together, isn't it? This is also the example of static friction. Then we have most common example is this example, table lamp resting on the table. This is you can easily understand it, isn't it? Let us say in our example, let us say this is your table lamp and this is your table, okay, on which it is put it. Then what will happen in this area? There is a friction, isn't it? That type of friction is known as static friction. We can say this is most relevant example out of all three. Okay, now you will see the we are discussing about friction, then how we can measure it. So the answer is we are measuring with the friction is via special concept known as coefficient of friction, or we can say it is the index of friction. We can also say coefficient of friction is nothing but the index of friction, which gives us how much amount of friction is there between two surfaces, okay, in the static friction. And which is calculated by using the formula Fs equal to less than or equal to mu s into n, where this F is static frictional force and mu is nothing but this coefficient of friction. This is denoted by coefficient of friction, and yes, this n is normal force, on which see when we discuss about the static friction here, this table will always act a normal force on that particular lamp, we can say, isn't it? So this is normal force. Or formula for calculating static friction is less than or equal to coefficient of friction, which is denoted by a Greek letter mu, S for static friction, and this n or normal force, we can say, which is also called as Fn. We can write n or Fn, isn't it? So in this way you can calculate the static friction, where this mu is known as coefficient of friction, and which is also known as index of the friction, or what we can say in our general term, how much amount of friction is there, which is given by this coefficient of friction. And most important thing, the value of mu is always less than 1. It is in between 0 and 1, we can say. Okay, now we will see second type of friction, that is sliding friction. Okay, now basically when we define the sliding friction, it is also the resistance that is created between any two objects when they are sliding against each other. So that type of friction is known as sliding friction. When any two surfaces slide against each other, the generated frictional force is known as, or generated friction is known as sliding friction. Okay, now we will see the examples, or a most common example, we are using the sliding windows in our house, isn't it? So when we slide them, so there is a friction, isn't it, between the lower surface of that window and the fixed surface, isn't it, of our window, whatever the space provided for that window. So in between upper surface of that face, so in between there is a friction. So this is the common example. Then we can say the sliding of the block across the floor. Most of the times during construction work, so blocks are slided, isn't it? So this is also the example of sliding friction. And here also we can measure the amount of, or index of this friction, this particular friction, by coefficient of sliding friction here. So this is coefficient of sliding friction, and formula for which is Fs equal to mu s into Fn. Again, mu s is the static friction, sliding frictional force. Fs is the sliding frictional force, mu s is the coefficient of friction for that sliding frictional concept, sliding friction activity, and Fn is the normal force, okay, as we already discussed in the previous case. Now we will see third type of friction, that is known as rolling friction. Okay, now the force which resists the motion of a ball or a wheel, and this type of frictional force or friction is known as rolling friction. Okay, when the object is rolling, we can say the simple example is ball, isn't it? When so during the motion of that ball, the force which resists this motion of the ball, so is known as rolling friction, or the friction there is known as rolling friction. Okay, and is the weakest type of friction. So out of these four types, this is the most weakest type of friction, or we can say it is having the force is very low in in this type of friction. In case of rolling friction, the frictional force is very low. We will see the common examples. Let us say wheels moving on the wheels of the moving vehicle on the road. Then we might have seen the ball bearings in our bicycles, or in our fan, we can say. So these are the examples of rolling friction, isn't it? Again, we can calculate the coefficient of rolling friction with the help of formula Fs equal to mu r into Fn, where Fs is frictional rolling force, or we can say frictional force of due to rolling. Then mu r is the coefficient of rolling friction, and Fn is the normal reaction. See, this mu r is in this case, or mu s in previous case, this is the constant value, isn't it? And this is known as index of friction, which gives us how much amount of friction is there in that activity. Okay, now we will see basically when we discuss about the rolling friction, it consists of two motions. First one is a translation motion. See, in rolling motion there are two motions, either it is translational motion or it is linear motion. Okay, in case of rolling motion, different points have combination of linear as well as rotational motions. Okay, so we will see this, let us say we will see this diagram, we will come to know. So in this diagram, if we observe, so I'm discussing about this diagram. Okay, if we consider only the rotational motion, then the we have to consider this point B here in both cases. Okay, so let us see, if we consider the rotational motion only, then the point B here in first diagram, it tends to move in the backward direction, isn't it? When this object is rolling, when we consider rotational motion, this ball as the object moving towards this direction, the point B tends to move in this direction or backward direction. Okay, and velocity is, let us say, Vr. Okay, similarly, if we consider the linear motion, so here also, if we consider in this diagram, if we consider the linear motion, then the point B moves with a velocity then the point B in this case moves in forward direction, isn't it, with a velocity VL. We will see, say for second velocity, it is for second case velocity is VL. Okay, now if I want to calculate the resultant motion of the point B, okay, I am discussing about the point B. See, first case, when we consider the rotational motion, the point B will tends to move in the backward direction with a velocity Vr, and when we discuss about the linear motion, the point B moves in a forward direction with a velocity VL. And when we calculate the resultant motion, will be the superposition of both the velocities, that is Vr and VL, isn't it? Now, depending upon the value of Vr and VL, the rolling friction can act in this following direction. It all depends on the value of Vr and VL. Okay, now we will see some cases, the possible cases. Let us say in first case, if the value of Vr, this case, the value of Vr is greater than VL, then the friction will act in the forward direction, isn't it? The moment of the friction, we can say it will act in the forward direction. Now, if the value of Vr in the second case, let us say value of the Vr is less than VL, isn't it? Then the friction acts in the backward direction. We can say the frictional force will act in the backward direction. And if the value of Vr and VL are same, okay, we can say that the frictional force will be zero. There will be no frictional force. Okay, we can say that there is a nil frictional force or zero frictional force in this way. So this type of, in this example, or with the help of this example, we can see the concept of rolling friction. Rolling friction consists of two types of motion, rotational and linear. In case of rotational, velocity is Vr. In case of linear, velocity is VL. And depending on this velocity, we can define the friction or the location of the friction or the direction of the friction. If Vr is greater than VL, friction will in a forward direction. Vr is less than VL, friction is in backward direction. And if Vr and VL are equal, then there will be no friction, or frictional force is zero, we can say. Okay, now after that we will see last type of friction, that is fluid friction. Okay, so this type of friction is basically, it exists between the layers of the fluids. Now when we discuss about the word fluid, most of the students thought that it is a liquid kind of thing. Fluid means what? It may be air or it may be liquid. Okay, air and liquid both are called as fluid, isn't it? So let me clear this thing first. Fluid means what? It may be air, it may be liquid. Okay, the friction that exists between the layers of the fluid when they are moving relative to each other, so that type of friction is known as fluid friction. Okay, now the examples of fluid friction is that common example we might have cross across in a day-to-day life, that is the flow of ink in pens. When we write down, what will happen? One layer of that ink will slide over the other. One layer of that link will overcome the other layer, and there will we get the letters and words and likewise sentences. This is the example of fluid friction. Or we can say the example of swimming, or various losses in pipe. When we see the pipelines, isn't it, due to the bends or due to the enlargement, reduction in area, there are various losses. So why these losses are happen? Because of this fluid friction. Okay, now we will see what these we have seen up to this, how the friction is classified, or what are the various types of friction. Now we will see what are the various effects of the friction. So most dangerous effect is it causes wear and tear. Due to the friction, what will happen? Wear and tear will be there, and what we can say, life expectancy gets reduced because of this friction, isn't it? Then we can say power loss is there. As we already know, if there is a friction, let us say I'm running a bike, and in the engine part, the piston, and say in between piston and cylinder, or the crank shaft of the engine is if there is a resistance, we can say there is an obstacle, or there is a faulty bearing, or a wear out bearing is there, then what will happen? Power loss is there. Okay, actual power what we have to need, it will not get with us, isn't it? So power loss is there. And we can say the because of friction, it is also having positive effect. So these two all are the negative effect, we can say, out of four. So we can say it is having positive effects also, like because of friction we are able to walk, isn't it? So when we walk, there is a frictional force in between the lower surface of our shoes and upper surface of the ground. Unless if there is no friction, we are unable to walk or even stand, isn't it? So this is the positive effect, we can say. Or we can say, when there is a friction, there is a production of heat, which will might be useful to us, isn't it, in most of the applications, thermal related applications. So these are the positive effects. Or we can say n number of effects, like friction produces noise, so most of the cases it is undesirable, isn't it? Or some of the cases it is desirable in case of musical instruments, likewise. Okay, so when we discuss about this concept effects of friction, it is having two sides. It may be positive, it may be negative, isn't it? Now we will see next. As we all know, there are effects of friction in both directions. It is in positive way, or it is in negative way. So if I want to get the positive effects, I have to the time need of the hour is to increase the friction. If I want to if I don't want the effects, or let us say effects are negative, I am interested to reducing the friction, isn't it? So we will see the methods of increasing and reducing the friction. Okay, so we will see firstly how to increase the friction. Now we can say, as we all know, if there are more irregularities on the surface, there is a more friction. So the most important or the most easiest way to increase the friction is increasing the roughness of the surface. If we increase the roughness of the surface, you will get more irregularities, and thereby the friction gets increases. Okay, so a common example is texture provided. If we see our sandals or shoes, or even say tire of our vehicles, even two wheelers or four wheelers, particular texture is provided, isn't it? So that texture provided, that texture will provide texture means what? There is a irregularities or roughness, it will create roughness, and thereby we will get more friction, isn't it? Now how we can reduce the friction, second part, by providing the lubrication. What do you mean by lubrication? Means what? We are generally, in case of machinery parts, friction is non desirable, isn't it? If there is a friction, there is a power loss. So what we are going to do, we just provide lubrication to the bearings and our day to day or common rubbing surfaces, isn't it? We are providing either oil or grease, so that type of lubrication is provided there, so that there will be no friction, smooth running operation will be there, isn't it? So in that way we can provide the lubrication to in order to reduce the friction. Then we will use ball bearings, isn't it? So balls are the rolling elements which will reduce the friction. Most of the times we have, if we often have seen, if our if our fan is creating noise, irritable noise, isn't it, which is quite irritating, then the mechanic will, when the electrician will open our fan, if you observe the bearing, the balls gets destructed, or there is a what we can say, the pitting kind of failure will be there inside the ball. It means what, the ball gets damaged because of this continuous friction, and hence we can provide the new bearing so that noise will not generated. So in that way you will provide the ball bearing, so that thereby we will reduce the friction. In that way we can either according to the depends on the application, either we are using these methods, isn't it? We can increase the friction by providing the roughness, and we can decrease the friction by providing the lubrication, as well as use of ball bearings and other types of bearings also, isn't it? Now we will see what are the advantages and disadvantages of friction. So we will see the firstly advantages. Friction between the pen and paper, so I am writing here, isn't it? So this is why, because of friction only. Because of friction between the pen and the paper, I am able to write on this particular slide on the paper, isn't it? Second advantage is friction between our feet and ground, isn't it? It allows us to do the various movements like standing or walking or running, we can say. If there is no friction, it is not possible to even stand on that ground, isn't it? Then friction between the surface of the road and the tires of our vehicle, so it will allow us allow the vehicle to move without slipping, isn't it? Most of the times what will happen in rainy season, due to the heavy rain, the road surface are wet, and what will happen, accidents may happen, isn't it? So this is why, this is because of reduction in friction. In that case friction is desirable. So these are the advantages, as well as there are some disadvantages also, isn't it? Like friction produces heat, isn't it? When two surfaces will rub against each other, there is a heat production, and this heat causes wastage of energy in machines, isn't it? Or because of the heat there are other bad effects are also there. Likewise our grease gets due to the heat, grease gets converted into liquid form, and all these negative effects will be there, isn't it? Then because of temperature rise, so it is not possible to withstand that particular part of the machine or engine, we can say. So that friction is not desirable in that case. So then friction causes wear and tear, as we all know, of the moving parts or machineries, or even say, we common example is soles of our shoes. So in that case friction is not desirable, isn't it? So we can say this is the advantages. And third one is friction produces noise in machine, which is always noise means what, unwanted sound, we can say. And if we it is irritating, or we can say it will create noise pollution, so it is also non-desirable, isn't it? So in that way there is also advantages and disadvantages of this friction. Then we will see the applications of friction. Okay, now there are various applications. I will put 3 to 4 application here. Friction finds the application when the matchsticks are ignited, isn't it? We are igniting matchsticks. If there is no friction, so we are not able to ignite that matchstick, isn't it? Then common example in the engine, most of the pistons in the engine, inside the engine cylinder, is an application of friction, isn't it? If there is no friction, there is no motion, isn't it? Or we can say, if there is a friction, we can say, let us say, if there are irregularities inside the cylinder, so there will be power loss, okay? Or we can say the proper combustion will not be there, or if your piston will not move properly smoothly inside this engine cylinder, you will not get the proper power at the output shaft or crankshaft, isn't it? In that case friction is not desirable. So we can say that as we are discussing, it is possible to write on board or on paper, so like I'm writing here. So this is because of friction only. friction between the pen and the board. So in that way you can say that friction is useful. So in this way we have seen the various types of friction, advantages, disadvantages and applications of friction. I hope you will understand it. Okay, if you have any doubts you can ask me. Okay, thank you.